We're now at the third phase of the pitching motion, which I've termed the arm acceleration phase. Just to briefly recap, we start with the windup. We got to the posting position. We then did the stride, and we're now ready to accelerate our arm. So again, we have our arm cocked here in a 90-degree angle. Our leg is firmly planted on the ground. Our back leg is extended. Our hips have only slightly started to open and rotate as we hit the ground. And right now, since we've just landed, we've imparted all of this energy that we generated during the stride phase into the ground, and the ground is transferring that energy right back up through us. So our goal now is to transfer that energy as efficiently as we can while we release the ball. The arm acceleration phase is very quick. It is from here to here. That's all it is. But it's one of the most violent motions in all of sports. It's one of the fastest movements that the human body does. During part of this, your shoulder is rotating at 7,000 degrees per second. It's just an incredible torque on some very small joints here, being your shoulder and your elbow. And it's very important to have the right positioning and the right flexibility in order to limit what can be some very serious injuries from this phase. So again, let's get here. We've just ended the stride. We're cocked. Now what do we do? First, you should take your lead elbow right here, and we're going to pull down towards our hip. We're going to literally pull our torso in a rotating manner using this front elbow here. Now, what happens first when I land is that my foot slowly opened up so that it was pointing to the catcher as I landed. Now, doing that, it started this chain reaction of energy. So my hips have now begun to open. They'll be the first ones to generate some torque here. My shoulders are still in line with the catcher. Now, as this starts to rotate, as my hips start to rotate so that they can face forward, that is when I'm going to start to rotate my torso and in turn pull my elbow down, and that helps this torso rotate. So first we have the hips are opening, and now the torso is opening. And if you notice, my arm is just acting as a whip back here. It's actually not, I'm not really forcing anything. I'm just going to allow what's happening from all these large muscle groups. All that rotation is going to cause my arm to do what we want it to. So hips, now my torso is opening. This is going to lag behind. It's going to put some stress on this shoulder right here, but we're in a safe position. We've got the elbow and the shoulder in line. Now I'm going to switch to this view. So again, we've landed. Now my hips started to open up as I landed. Now I'm pulling my torso, my shoulder, I want to keep upright and in line. But now as they rotate forward, and again, keeping my elbow at 90 degrees as well, my hand with this baseball in it is actually going to lag behind everything else. It's just an incredibly quick movement, and the hand itself just kind of lags behind. Now, if you notice, if you were to slow motion this, actual throwing motion, the hand actually goes pretty far back. It goes, further back than I can actually physically move it right now. It moves approximately perpendicular. Some people, it even goes below that, putting a ton of stress on this elbow. But that's really, once it reaches that peak flexibility, that's the whip that is going to generate all that speed. So for here, I've rotated. Now, the part of this phase that can be very dangerous and cause what's called the ulnar collateral ligament tear is what we were just talking about. This movement from back here into the whipping motion forward towards as we release. They've done some studies, and so we'll say this is 90 degrees. If I was to release the ball here at 90 degrees, this is 3/4, commonly referred to as a 3/4 arm slot. And here is, we'll put this at 180 degrees. Now, in pitching, some pitchers like to get as far out here as they can because it actually allows some crazy spin on the ball, and the ball will tail a lot more than if you were to throw, even from further up top. There's some pitchers that, will come more over the top, and it's very, very straight, just the rotation of the ball. Whereas out here, it's going to impart a very different spin. However, I wouldn't recommend going any further than 3/4, then we'll say 135 degrees, because the further out you get, they've noticed that the more lateral you get with this hand, the more likely you are to have UCL injury, and which is commonly fixed by the Tommy John surgery. It's very common among major league pitchers, unfortunately. Just a ton of wear and tear along this elbow. Now, so let's return back to our torque here. First was our hips, then we had our elbow help us kind of timing wise rotate our trunk. And now the first actual thing to recover as part of my arm is not my shoulder, but it's actually my elbow. Now they've both rotated here together, but my elbow is the first one to bounce back. Now, so as it bounces back, my shoulder is lagging a little bit behind. I've just externally rotated the shoulder as it flexed like that, and now we're internally rotating, and this is where you get all of the final power and speed as this internal rotation goes at the 7,000 degrees per second that I mentioned earlier. It's just an incredible amount of force in a very short amount of time, and that's what causes baseballs to travel at 100 plus miles an hour. Final comment on this is your release point. It will be natural. It's not really something you think about, but the release point tends to be, for pitchers, to actually, it's going to release at approximately your toe. If you want to take some slow motion videos of yourself pitching and see, a natural arm movement will release the ball approximately over your toe. And that's when the arm acceleration phase ends. We stride, plant, arm acceleration phase begins, and it's just a throw, right? It's going from here, generating a whole bunch of torque and momentum in order to release the baseball at approximately this point. And that's the arm acceleration phase.